In this video, we're going to do a few more examples dealing with finding limits using the L'Hopital's rule. Okay, so the first example is going to be to find the limit as x approaches infinity of square root of x squared plus 1 minus x. Okay, so if you try to break this up into a fraction somehow, um, you can try doing it like this: x squared plus 1 over square root of x squared plus 1 minus x squared over x, but that would create more problems because then you would have to make it into a single fraction to use the L'Hopital's rule, and if you try to differentiate, you will have just way too many terms. So the easiest method is to actually erase this, okay, and use the fact that you can multiply this by the conjugate of this expression. Okay, so what I'm talking about is this: as x approaches infinity, you can take square root of x squared plus 1 minus x, and then multiply both sides, right? So imagine that this is over 1, so you're going to multiply by the conjugate of this numerator, right? So it's going to be x squared plus 1 plus x. And both sides, right? Because you don't want to violate the concept of 1. So x squared plus 1 plus x. You see? And that way, you will have something really cool happening, because it will eliminate the so many terms. It will eliminate extra square roots that we don't need. Okay, so notice that the first term, using the FOIL method, of course, you will have x squared plus 1 outside, right? No square root because you got rid of it by squaring it. Then the middle two terms are canceled out because the alternating signs. And finally, the last term is just minus x squared, right? And this is divided by x squared plus 1 inside the square root plus x. And notice that the x squared, they canceled out. So as x approaches infinity, you will just have 1 over square root of x squared plus 1 plus x. And then you can plug in the infinity here for the x, and you will get infinity in the denominator, right? So you will get 1 over infinity, which is equal to 0. There you go. Okay, now the second example in this video we're going to look at is going to be the limit as x approaches infinity 1 plus 1 over x raised to the x power. So as you can see, if you try to evaluate this limit as it is, you will get an indeterminate form, and I will just show you what it's going to be. 1 over infinity is 0, right? So you will get 1 raised to the infinity. That's an indeterminate form, so you have to get rid of it. So in order to get rid of it, we're going to set the y equal to 1 plus 1 over x raised to the x power, right? We're going to treat it like a function, okay? And then ln y will help us get rid of that x power and rather multiply this inside, right? So ln of y is going to be x multiplied by 1 plus 1 over x. You see? So now we're going to calculate the limit as x approaches infinity of this ln y, okay? Right, so we just copy this down, so we're going to have the limit of this, right? And then we can rewrite this so that we can use the L'Hopital's rule, because if you try to evaluate it, you will get let's see, 1 over infinity is 0, 0 plus 1, so 1 times infinity, you will just get infinity, right? And e to the infinity is an indeterminate form as well. Okay, so so in order to get rid of this problem, you're gonna rewrite this. Okay, you're gonna rewrite this. Oh, sorry, did I forget the ln? I think I forgot the ln. I forgot the I forgot to put the ln here. Okay, so x ln, right? X ln 1 plus 1 over x. That makes sense. Okay? Basically, when you take the ln y, you will take the ln of 1 plus 1 over x to the x power, and the x goes down as a result of having the ln, right? So this is what you get. So now I have to install here the ln really quick, just to correct this issue here. Okay, so it's going to be x ln of 1 plus 1 over x. So now if you try to input the infinity, you will get ln of 1, right, which is 0, right? And just going to erase this really quick to show you what the indeterminate form is going to be. So it will be 1 over infinity, 0, so ln plus 1, ln 1 is 0, and then infinity. Infinity times the 0, right? Infinity times the 0. That's an indeterminate form, right? So you have to obviously rewrite this expression, right, as ln of 1 plus 1 over x divided by 1 over x, right? Because that's the equivalent. 1 over x in the denominator is the same thing as x multiplying the ln. So now if you try to evaluate it, you will still get an indeterminate form because 1 over infinity is 0 and ln 1 over is 0, right? So you'll get this. That's an indeterminate form. So you have to now use the L'Hopital's rule. You ready for that, right? Okay, so first the derivative of the derivative of ln, so you take 1 over, well actually let me indicate that we're going to take the derivative first. Okay, so the derivative of ln of 1 plus 1 over x with respect to x over the derivative of 1 over x with respect to x. Okay, so that's going to give us derivative of the ln first using the chain rule, right? So 1 over 1 plus 1 over x times the derivative of the inside. That's 0, and the derivative of 1 over x is going to be negative 1 over x squared. And this whole thing divided by the derivative of the denominator, which is negative 1 over x squared. And guess what happens? These two guys cancel out, right? So you will have, as a result, 1 over 1 plus 1 over x, which can be rewritten algebraically as you can combine these fractions. You'll get x plus 1 over x, so x will go on the top, so it'll be x divided by x plus 1. And now you can evaluate this. Well, rather you can't yet, because if you plug in the infinity, you will get infinity over infinity, which is still an indeterminate form, right? So you still have to use the L'Hopital's rule one more time just to make sure that you will get rid of it. Okay. Well, what if we were to avoid the L'Hopital's rule? What if we, well, let's see, x squared minus 1, x squared minus x. Well, no, we can't do that. Yeah, we can't do that. X squared minus x, and this x squared. No, we can't. I was thinking about multiplying the numerator and denominator by x minus 1, the conjugate of this, but it's easier just to take the L'Hopital's rule, okay, rather than do that. So in this case, so we're going to take the derivative of x with respect to x divided by the derivative of x plus 1 with respect to x, right? So that's going to give us, as x approaches infinity, 1 over 1, right? And that gives us 1. But we're not quite done yet. This is not the limit of the original function. This is the limit of the ln of that function, right? The limit of this, right? Just to make sure you remember that this is this of ln y. So now, in order to find the y, the limit of the y itself, you will raise this ln y as a power to the e, right? So e will be raised. So, right, limit of as x approaches infinity of y is going to be e raised to the power of ln y, right? The limit as x approaches infinity of e to the ln y. And guess what happens? We already found out what the limit is of ln y. It's just 1, right? So it's just e to the first power, which gives us e. So there you go. That's your limit value. Thanks so much for watching this video. Please subscribe to my channel, and I'll see you in my next video. We're going to talk about the final 2 examples dealing with limits and finding them using the Hopital's rule. Thank you so much.